Hi, well, good afternoon, everybody. My name is Ian Gray. It's a pleasure to be here virtually this afternoon. It's one of my great personal disappointments that I've not been able to travel across to Portugal for this summit. But it's great to join everybody virtually at this conference. The theme of the summit is all around digital. Seems very appropriate. I think the last 6 to 9 months have shown to us just how dependent we all are on digital. And even today, I know that we've had 1 or 2 gremlins and small problems, people trying to log in. So we'll try and get through this session as efficiently as we can. I have listened to a number of the sessions before, and an overarching message I got was it's not just about the science and the technology, it's about the application and it's about the business role. So I think we've got a panel this afternoon which really kind of reinforces that. It is about business, and we've got representatives from the OEMs, from the MRO world, and from the and from the airlines. Just to introduce briefly the panel, we've got Patrick Wood, CTO and Engineering Director of Marshalls. We've got Steve Sheely, who's the VP for Sustainment Strategies and Business Development at Lockheed Martin. Alexander Altuon, who's Business Development in Digital Services in Airbus. And in the studio itself, we've got Joe Ferreira, who's the Innovation Manager at TAP. And what I'm going to ask in a few minutes is for those people to share some short thoughts and presentations, and then we'll move on to a Q&A session. I have found listening to the sessions this morning really interesting, and topics like applied AI in terms of driving solutions, in terms of inspection, analysis and repair, robotics, the implementation of augmented reality, all great technology ideas and solutions in their own right. But one of the again, key themes that I picked up in an earlier session was, are they mature enough yet? Can we rely on them enough yet? Do we have the confidence enough in them yet to take them on board in the world of MRO and airlines and OEMs? From my own personal perspective, I've been very much involved in digital transformation in terms of design for manufacture, and I wonder and challenge whether we have embraced the world of digital as fast in the world of the MRO as we have in the design and manufacturing world. So it'd be great to hear from our panelists today on what their views on that are. There's no doubt that COVID has seen, certainly in the world of civil aerospace, unprecedented actions being taken. And one of the actions the airlines have been taking is to retire much earlier than perhaps they'd ever expected some of the older aeroplanes. So, we are seeing in the world of civil aerospace huge demands in terms of increased operational reliability, reduced times between inspections. And I'm sure all of that, while providing lots of benefits, will bring its own challenges into the business models of the world of MRO. I'm also fairly sure that in the world of defence, long-term plans in terms of increasing reliability have been part and parcel of the military aircraft specifications now for a couple of decades, and we're reaching that point where we're just looking at what are the realised benefits of many of the thoughts and ideas that we've had over the years. So what I'm going to do in the first instance is I'm going to ask Patrick Wood, who's the CTO and Engineering Director of Marshall, if he could just share his thoughts. Patrick, I note that you're not on camera at the moment. I know you do have a slide that you wanted to share, but I'll leave you to manage the screen as you wish. Patrick, over to you. And you're still on mute, Patrick.
No, thank you, Ian, very much. And I was going to try and share a backdrop. So let me just see if I can do that. It doesn't look like the icon is shaded out. So it was just a fantastic picture of a C-130, of course.
Well, Stephen would have loved that. Thumbs up from Stephen.
So if we just, but I in front of me, behind you, Steve, I can see a picture of a C-130. But no, thank you for the opportunity to speak at this panel at the Portugal Air Summit on digital MRO. I think it's such a key topic, and it's one that's really developing so rapidly. It's certainly a key topic for Marshall Aerospace and Defence, not only for the operations team, but the whole design team, the supply chain, quality, safety, and in aiding our customers. And the one that, and in particular myself as the CTO, I'm getting involved more and more in the research and development topics that are associated with digital MRO. Predominantly, we support the Lockheed Martin C-130 medium transport aircraft with over 19 customers globally. But with our special missions aircraft, we also have a mix of aircraft types to support, as well as aircraft that have been in service a long time before anyone thought of digitization of the MRO activity. So we're based here in Cambridge in the UK, but we also have facilities in Canada, and both of those facilities support MRO activities. Our purpose is to support people in critical situations, so the ability to improve the efficiency of our MRO tasks enables us to support our customers more effectively and maintain fleet availability for those customers, which is, at the end of the day, the most important aspect. It's also an exciting time from a digitization of the whole business, from the first concept on an aircraft all the way through to the development and manufacturing life cycle, and then seamlessly into the through life support aspects and MRO activities. The whole purpose is to use digital processes to make MRO more efficient and cost effective, and hence reduce cycle time and increase hangar slot utilization. So the use of technology not only covers the design, modification and manufacture of aircraft, but extends it through life and the MRO activities. So now, historically, Marshall's probably been known as quite a traditional company in the approach to MRO, but this is changing. In recent years, more and more digitization is occurring on the maintenance and repair side, particularly of our military aircraft, but also of our special missions aircraft. And I often summarize the priorities around digital MRO as the word pave, in terms of paving the way, predicting in advance, augmenting the workspace, visualizing the data, and adding efficiency. And Marshall has been approaching this digitization in a number of ways over the last few years, using digital data to throughout the life cycle of a project, using digital analysis and test tools to speed up the analysis of inspection of aircraft, whether that's it's a digital dent mapping and analysis software, to the ability to laser scan areas of aircraft to provide accurate models for repair and modifications in the case of dents or damage to aircraft. Digitizing the data presented to technicians and fitters. How do we actually more efficiently present that data so that the technicians and fitters can use them more effectively? Predicting the issues from a fleet knowledge as well as a specific aircraft data is something that we've been doing a lot more in recent years. So in pilot schemes, we're seeing the ability to predict almost 80% of the tasks for a particular aircraft prior to that aircraft actually arriving at our hangar. And that's allowing us to optimize our stores holdings, to make sure we're efficient in the way we're organizing our digital work cards, and improving the use of our integrated enterprise resource planning tools to make sure that we bring together all of this company data to be far more efficient. And of course, it's more effective access from the technicians directly to the design data. So we've done a lot in terms of opening up our product lifecycle management tool to enable the technicians and fitters to get access to online, up-to-date configuration control data. But of course, 2020, as Ian mentioned, has been a rather challenging year, but it's also in some ways had some opportunities. We literally went in one day from being an on-site working organisation to 50% on-site and 50% complete remote working. And we've certainly taken advantage of new tools in terms of being able to do that. But we've also been able to integrate those tools. The design engineers can remotely access their design workstations. We're using a lot more integrated collaborative tools like Microsoft Teams. And we're using the Teams aspect of that to actually bring teams together virtually to enable that working environment to be maintained as much as possible. We've increased the availability of mobile workstations for the technicians, as well as using digital tablets for viewing data at the aircraft. So we historically have not done that, but we've got a number of initiatives that are now doing that. And we're using, as I say, collaboration tools like Teams far more extensively than previously. Remote team working is now standard with mobile devices, enable team members to participate in everything from the daily stand-up team meetings using electronic whiteboards, but also participating in meetings. And actually, in the virtual world, if everybody's locked down, that's a sort of manageable situation because everybody dials in remotely. Some of the challenges when you have a half and half, when you have a team that are half remote and half in a hangar, and actually learning the procedures and processes to make that work and training your team leaders to work effectively. So again, this is all helped with the digital transformation. And one feature in 2020 is the remote viewing by customers. So we've actually done quite a lot of interactive viewing by our customers, as well as pre-recorded videos to enable them to really see how effective the repairs are. So today we use digital twins in the design and modification of aircraft, digital simulation and modeling to make the design and manufacturing process more efficient. But the use of these model-based systems engineering approaches not only helps the design phase, they become key as these aircraft go into service. The digital twin will take on a much bigger role in predicting future service, MRO tasks and activity. One digital MRO area we've been supporting our customers with it for over 30 years is structural health monitoring to improve operational load monitoring, and being able to use this data to predict aircraft performance as well as predict future MRO needs. So the use of predictive data analytics, machine learning, and artificial intelligence are now well-established topics within our R&D activities to support digital MRO and future MRO activities. Use of robotic inspection will, of course, evolve. We've used drones to survey aircraft with some good results, but we continue to explore this technology and the use of the sensors. It's an exciting area and one that will evolve, but the fundamental building block is the use of 3D data. Without the use of 3D data, you can't really build a digital MRO in terms of the use of the capability. And of course, we do a lot in additive layer manufacturing. So we currently have aerospace qualified tertiary parts and structures, and we're got R&D activities from our MRO to look at secondary and primary structures in the future. So I just wanted to conclude, looking at the time. Digitization of the MRO is here. It's providing more effective and efficient ways of working. In 2020 has seen an acceleration of many aspects of the use of digital data and analytics to help the MRO process. And this trend will continue to drive more predictive data analytics, more augmented data, the use of machine learning, artificial intelligence, as well as better visualization of data. And all of these will result in more efficiency, reduce cycle time, and increase hangar slot utilization. So thank you very much for this opportunity to outline where Marshall Aerospace and Defence is and the exciting topic of digital maintenance repair organisations.
Okay, thank you very much, Patrick. And if you could stay on the panel for when we come back to Q&As, that would be brilliant. What I'd like to do now is move over to Stephen Shee from Lockheed Martin, who I think wants to talk a little bit more about some of the initiatives around things like the F-35 program. Stephen, over to you.
Ian, thank you very much. Let me share my screen real quick here. Hopefully you can see that now.
Yes, we can, Stephen.
There we go. Perfect, thank you. At Lockheed Martin, we're focused on the warfighter. You look at our products, and it's great to be on the virtual stage here with a great colleague from Marshall's, but we're truly focused on the warfighter. That's the person who's using or maintaining our product on the flight line or on the ship deck. It's our goal to make their lives easier and more efficient. About 3 years ago, we took on a concerted effort to bring automation and digitization onto the flight lines and into the hangars for those maintainers, technicians, and engineers to make them more efficient and have greater information at their fingertips. From dashboards that our item analysts use to visualize and prioritize outstanding demands in real time, to robotic process automation that frees up our teams from repetitive tasks. We're building a sustainment success system with the right tools, processes, and workflow to improve performance and support our customers. The autonomics and digitization of our maintenance and repair actions sit around 4 areas. And the slide here is just to help me walk you through those. Those 4 areas are the high reliability of our platforms, predictive health and analytics to help us drive to that high reliability, high velocity supply system. Aircraft don't fly without having the right parts there. And now all 3 of those, the high reliability, predictive health, and high velocity supply, all drive to our condition-based maintenance philosophy we have for frontline fighter aircraft. I'm going to walk through these 4 here. And what I want to highlight is what Ian brought up earlier. What I'm going to be talking about are things that are happening today on the F-35, not in the future, not planned to be, but are operationally being used out there by the men and women who fly and maintain the F-35 around the globe. I'll start with high reliability. High reliability starts with understanding what the parts on the aircraft and for us in the entire air system are doing. We've started electronic equipment logbooks, or what we call EELs. They're based on legacy logbooks, like a lot of us have, paper and spreadsheets. We've advanced it to a digital collection of both current and historical configuration information on those parts, lifing information, usage and repair information of that part, inspections required for that part, and mods done to that part. You know, these are all critical items of the air system. When I say the word part, I'm not talking just a line replaceable unit or black box on the aircraft. I'm talking structural components on the aircraft. I'm talking about low observable stealth panels on the aircraft. All that's being tracked. We're doing that so when a part moves from an air base to a repair facility to a warehouse, we had this EEL moving with them. The history of that part, regardless how big or small it is moving with that part. It includes, tracking flight hours, so we can drive engineering and R&M analysis into our systems. We also include parts that don't have inspections or life-limiting tracking against them today, but may in the future. It's our belief, if usage isn't tracked from the beginning, then our R&M world comes down to guesswork when an inspection is really needed, when inspection is authored. We want to have that data early on. That's one of the things driving our high reliability, tracking that lifing of that part, what that part goes through from birth to death of that part. I'll move down now to predictive health and on our analytics here. On the F-35, we have a prognostic health management system. It's driven by artificial intelligence, algorithm-based prognostics that literally estimates when components will likely fail or when service of maintenance is required on the aircraft. It will tell us when a part's about to fail. That's pretty straightforward. But also, the aircraft will tell the technician or maintainer out there that in the next 5 flight hours, you need to service oxygen, you need to service engine oil. That is all being done with over 50 structural condition-based maintenance algorithms on the aircraft, 8 vehicle system algorithms, 2 electrical system algorithms, 8 mission systems watching our software, and 63 propulsion advanced lifing algorithms. They're being used today. And we've gotten to a point now where fault detection on the F-35 using the prognostic health management system is at 98%, which I find, since the aircraft's only been flying operationally since 2012, outstanding. The prognostic health management system has gotten better over the year as we mature the system, learning more about the aircraft. It's allowed us to reduce our retest OK, or that is taking good parts off an aircraft, by 63%. The data we use in the prognostic health management, we apply machine learning and artificial intelligence into our product advance and maturation engineering process. It allowed us to eliminate engineering analysis and disposition by 1,700 fleet work orders each quarter. We're letting the machines do the work instead of the people, speeding up that process. It's also allowed us to decrease our root cause corrective analysis from months that people were doing down to days and weeks by using that machine learning and artificial intelligence. I want to step now across the slide, the high velocity supply system. Having that supply part in your hand when you need it, and having the right part there is critical, especially in the combat aviation world. One thing we've put into place that is helping us speed things up and also reduce manpower in the supply process is using robotic process automation, RPAs, or better known as bots. Or at Lockheed Martin, we call them our digital employees. RPA technology automates those repetitive tasks, the time-consuming tasks for our functional teams, but allows our digital workforce to permeate throughout sustainment and optimize our processes. Team members then, the physical team members, are able to focus and accomplish more strategic initiatives, while our digital workforce performs tasks like populating forms, pulling data out, doing process audits, and also completing systematic transactions we need out there. We started these digital employees back in 2018. We have 30 digital employees across sustainment now, with 5 more in development, or you could say our HR program is bringing on 5 more digital employees. Our digital employees have accounted for 60,000 annual labor hours through updating of 42,000 sales orders and processing 14,000 repair requests. Our objective, like I said earlier, is to process repairs in the supply system as quick as possible with minimal errors, so the part can repair and return to support the users out there so they can get back to their job. I'll move down to the cognitive data fusion. What we've done is taken the aircraft data fusion logic on the aircraft and pulled that into the logistics data world. We've used that, built algorithms, so we release these programs to review all our data quality out there. We look at our EOs out there, I talked about earlier, and we look for bad data. Bad data in this day and age stops everything. Our cognitive data fusion software we have out there literally has found in a 6-month period over 2,300 bad data packages. They're like ticking time bombs out there that would stop the process in our supply system. All these bad data packages were infused by people, but we're now using data fusion to cross-reference items to find these bad data packages early on. Last, I want to drive down to the condition-based maintenance. Condition-based maintenance on a fighter aircraft brings in what I'll call pure efficiency. And how we're doing that is we pull in all the other 3 aspects, but we had to have a digital platform to pull all the elements of sortie generation and global sustainment together. That system is called our Autonomic Logistics Information System, or we call it ALICE. ALICE is the single point that drives all of sort of generation for us. ALICE runs our pilot and maintainer training and training records. It runs pilot and maintainer debriefing. It looks at
Hello, Stephen, have we lost you? Hello, Stephen. Stephen, it looks like we've lost you. What I suggest we do is we'll move on to Alex, and Stephen, if we come back in Q&A, we can finish off the bit. But meanwhile, if the organisers could just see if we could sort out exactly what's happened with Stephen. Alex, can you hear me? Okay.
Yes. Can you hear me?
I can hear you. I can hear you. You well, Alex.
All right. If you can put the slides up, thank you. Bom dia, good morning, everyone. My name is Alexander Altman. I'm working on the business development of database digital services in Airbus. You can jump to the next page. I prepared just one slide here for my speech, and basically what we are doing here in Airbus with regards to data and extract insights and value from data. Starts in the very basic element, which is the data itself. So I thought it would be a good example to share with you today what we're doing with the military platforms of Airbus today. So the foundation is the ability of the aircraft to not only generate the data, but process the data. So we have in the last years already worked on improving the platform's ability to collect this data, and then so that we can use this to generate digital solutions on it. And that's what I have on the left side of the screen. So not only the data itself, but also the softwares on the ground that allow us to analyze and visualize the data. Now, if that's the foundation, and that has been the work that has been happening in the last years, then the stage where we are in right now is to basically generate the insights and the high added value that we can extract out of this data. And here, basically, I just listed some examples. It's not an exhaustive list, but we're also looking into how can we, working with the customers, how can we replace some of the manual processes they currently have today. So we're also looking into optimize the sequence of maintenance events, solutions linked to advanced diagnostics, or using data to make assessment regarding reliability of components. And the list goes on into 3D printing or aircraft digital twin as a tool to facilitate maybe the interaction with between operator and industry. Now, we try to look on those different technologies. Of course, I think like my colleagues already said, in the optics or perspective of increasing the asset platform availability, and at the same time reducing operational costs. Now, I think we can argue with regards to how fast this is moving or is not. I think my premise and my understanding here is that we're really talking about an environment which has very limited tolerance for any risks. So that could explain why things maybe are not as fast as some people could expect. Nevertheless, the digital revolution is there, and then we have to push the boundaries of that system with the data. So I think we are in the initial steps into what will be in the future. Let's say if we fast forward for another 10 years, what will those digital solutions look like? It will be very different than today. But nevertheless, I think industry is working in that direction. Create the insights based on the in-service data, and I also think this is bringing industry and operators very much close together. And yeah, this is what I wanted to share in 5 minutes.
Okay, well, thank you. Thanks, Alex. That was good and a different perspective again. And then, Joelle, you're in terms of the panel, you're kind of the inspiration for us all. You're there. You're in the studio. So, Joelle, can I ask you from TAP's point of view, TAP's point of view, just to share some quick thoughts from your perspective?
Okay, thank you. Can you hear me, Ian?
Yes, I can. Perfect.
Hi, all. Okay, since we are running out of time, I will try to be very brief in my first intervention. Let me start by sharing a little bit our perspective and the way we are approaching the digital transformation at TAP. TAP, for those of you who don't know, is the Portuguese flag carrier, which has embedded an MRO. Actually, it's not a separate entity. We are all part of the same company, the airline and the MRO. This has some advantages and some disadvantages. What I will share is how the MRO part of the business is approaching digital transformation. As you were saying in the beginning of your presentation here, I'm afraid that we are not being as fast embracing digital technologies as, for instance, design and manufacturing. So we defined a strategy to approach digital transformation, and we know that there are several aspects which are critical for a successful digital transformation for a strategy, and I would highlight 3 aspects of our strategy here. So we defined that we had to have clear targets to approach digital transformation so that all the people in the company understand what are the targets that we are working for. In our strategy, we identify that it's critical to have senior management buy-in. If not, it won't be possible probably to have all the resources needed to implement a successful digital transformation. And also a very critical aspect to a successful digital transformation strategy is to target quick wins, easy wins, right? Having this in mind, if I may start by establishing a difference that there exists in the MRO business, maybe you all understand what's the environment. I think that there's a clear differentiation between what I would call business supporting systems, which are the systems critical to support all our daily activities, to manage airworthiness and to plane maintenance and so forth, you know. And the decision makers in the MRO business today would perceive these systems as need to have systems to support our business. And on top of that, there are the data analytics platforms, which are perceived currently as nice to have systems, not need to have systems. But in my perspective, if I will have the chance later on to share it, I think also those will become need to have systems, the data platform systems. So what are we doing? We defined a near-term strategy and a medium to long-term strategy. You know the saying that says a chain is only as strong as its weakest links. It so happens that in our maintenance value chain, we have 2 weak links right now, because we are not completely digital. We have 2 very important pieces of information which are still paper-based, which are the work orders, the work cards that the technicians use to have the instructions to carry on their work on the aircraft, and the aircraft technical logbook. Until we have these 2 critical pieces of information in digital mode, we are not completely digital. We don't have our maintenance value chain completely digital, and we cannot release all the potential of a digital MRO. That's why our main target is to build the foundations for a digital MRO, which means digitizing work cards and the aircraft technical logbook. This is what we are doing right now. At the same time, we are modernizing our maintenance information system because you have to update your systems. The legacy systems usually are not connected to each other, so the quality system may not be connected to the planning, the maintenance planning system, and so forth. And so that's why we understood that we had to update our maintenance information system. We are doing this. And another thing that we are doing in our near-term strategy is to build some applications. We did a project with external partners focused on line maintenance, and we developed an application to support the decision making of the line technicians in line maintenance. We did this based mostly on aircraft data. We already have it in digital format, and maintenance manuals, because we also have it in digital format. But we know that we need much more. We need information from our maintenance activities, and that's why we have in parallel those initiatives to digitize work orders and the aircraft technical logbook. In the long term, we are testing the data analytics platform that exists on the market right now, and based only on aircraft data right now. But we aim, of course, to integrate maintenance history records as well. This was as brief as I could be, right? I'm open to questions now.
So Joel, thank you very, very much for that. Some interesting, really interesting challenges and links back on the cards and the aircraft logbook and things like that. I think this session itself has reinforced the advantages of digital. You know, we've joined US, Germany, Portugal, UK, all together in a virtual sense, but it's also demonstrated reliability issues and things like that. And going back to one of the questions in an earlier situation, you know, do we have maturity of technologies and maturity of the to actually make this step now into the world of digital MRO? Just a few very brief thoughts. Stephen, I'm sorry you got cut off, but do you think we're ready? Is the technology mature enough? Is it reliable enough to make this big step forward?
Ian, it's there to start. We can't go from 0 to 60 overnight. There's a stair-step approach to go. We have the technology there today, and again, our company is trying to prove that with the F-35. We digitize completely from the flight line all the way to the MRO and use with the aircraft and for components. We need to start with stair steps in all processes. So the technology is there today to do that, but everybody has to start at the first step and then move up.
And Alex, from an OEM in the civil world, I mean, listening to what Joel said about digital transformation, how do you kind of, you know, do you think we're mature enough? How do you address the question of what Joel quite nicely described as the maintenance value chain?
Yeah, I agree with Stephen. This is we're not going to move from 0 to 10 overnight. This there are different steps involved in this. On the other side, I also agree that it's not a technological issue here. It's more a complete. I think people have to get used to this. We have to adapt the processes. We briefly mentioned this before the session. The regulation is another component that plays a role here. I could imagine that there are differences on military and civil aspects, and how regulations play a role in this. But at the end of the day, I think will be a similar conclusion that is not an issue with the technology we have available today.
Okay, thanks, Alex. And Patrick, you know, you similarly raised, like Joel, the challenges of the kind of work cards and the paper-based system there. What do you think needs to happen, Patrick, to kind of address the challenges Joel described?
I think it's, you know, technologically, we have the ability to do that. I think some of it is driven by the heritage of the information and how that was created some time ago. We obviously respect the OEM's data format, and that's really essential. So some of that delays some of the transition to the digitization of all of those aspects. But I think with modern technology, many of those areas you can circumvent and get round in terms of being able to scan data in and then be able to use it in a digital world. So I think it's a challenge, but I think it's something that we'll evolve and fix. These issues are often, once they're in front of us, we find clever ways of solving them.
And Joel, final word in terms of, you are the end, well, you're not the end user, the passenger is the end user, but you are the end user in this particular value chain. And any kind of last thoughts from you, Joel?
No, picking up on what you were asking to the other panelists, if the technology is mature enough already or not. I think the technology is mature enough if we look at the developments of cloud computing, if you look at the amounts of data that we can get out of the aircraft right now, all those technologies, machine learning, artificial intelligence, they are mature enough. What I think is not mature enough are the companies and the MRO companies. We are a classical engineering kind of companies, right? Industry. And we are used to hire mechanical engineers, electronic engineers. Now we have to understand that we will have to start to hire data scientists and people dedicated to digital, people with more digital skills. This is not yet embedded in our mentality, but we have to definitely embrace this new reality, because it will bring us efficiency, it will reduce costs, and this will have a direct impact on the airline's bottom line. So that's why this is so important. Of course, it implies investment, and investment is always difficult to mobilize. But since this will have a direct implication in the cost reduction of the airline and the resources availability and in the efficiency of our processes, I think it's worth to make this investment.
Well, Joe, thanks for that. I think the whole skills agenda, we could go on for a long, long time talking around that, and I would love to do it, but we've run out of time. Can I just thank you as panelists for participating and for putting up with some of the technology glitches. That was great that we got through it. Thank you very much to the organisers for inviting us to today, and I think there's some real good food for thought in what's been discussed around the table today. So thank you everybody for listening. Let's close this session here. Thank you.
Thank you.